All right, folks. So I have a select set of items to discuss that have been listed on the agenda on the issue in this ECIP repository. I'm going to share my screen so you can see it with me. It's a rather big screen, so let me know if it's too big. And just wanted first thank you for coming. This is my first time organizing this, and by all means, I'm nowhere near the level of professionalism you would see from others. And hats tip here to Afri and others who've done this before. But I wanted to just have the occasion to talk. In particular, frankly, I'm interested in number 3 item on this, and to have some discussion about it. But so it felt like maybe a good time to also have a quick check with everyone. So if I believe we have members of most teams on this call. I can represent Hyperledger Bezu. I've seen the folks from Mantis and from CoreGeth. So I can go real quick. On the business side, Magneto was a success as far as I can tell. Everything went well. I'm currently running a mainnet node with the latest, and we're able to keep up with the network. Things are going okay. The Bezu team has been busy all over the place between all the work that they're doing on private permission networks and the work that they're currently visioning toward the next session. There was just a CoreGeth call on the Eve side where they were discussing that they might want to stop doing any big feature EIPs until the merge is done, which is going to probably freeze a bunch of feature development on that side. I implemented EIP 3704, which is kind of cool, to quickly how you could do on and off calls to pretty much so do as someone else on chain. So it's a nice little addition to the code. And that's about it for Bezu. Who would want to go for CoreGeth?
I can go. Can you hear me okay?
Yeah.
Yeah, great. I'm Isaac, work on CoreGeth, and Antoine has, thank you, Anton, first off the bat for being the initiator and primary author of this excellent PR to CoreGeth that has the Ketchup functionality. And at this point, CoreGeth runs it runs on Astor just fine. It mines also. I haven't tested the GPU mining with my own hands. I don't know if anybody else has anybody else tried that?
Yes, there's a Telegram group, and some of the miners there, they tried CoreGeth with the GPU miner, and it worked really well.
Cool.
Yeah.
Cool. Yeah. Yep. Yeah. It looks like the code should be there for it. So that's good to hear that it's actually passed through some hands. And right now we are working on refactoring it because there's, as some of you who are familiar with the code base may, or if you're not, may not be familiar, there's quite a few assumptions in the code about consensus engines and some of the configuration, specifically the configuration options and designs around that for questions and subjects like difficulty and rewards and stuff, and it's not perfectly separated out to have the engine separate from some of those other potentially sort of engine agnostic configurations that networks may or may not want. So so that's sort of the largest challenge, but so what we've been working on is just trying to really separate it, and luckily, as Antoine proved, we can pretty much just mirror the implementation of the ETH hash engine and just replace the hashing function. And so there are also some other questions. I think one thing I would that has come up a couple of times that I would love to see for Astor would be sort of just like a spec or any kind. It doesn't have to be like a fancy looking official kind of thing, but just some kind of a maybe like a design intention style document for what Aster is supposed to have on it, because that question has come up a couple of times. Like, is it supposed to have monetary policy? Is it supposed to have a difficulty bomb diffusion? Is it supposed to have
Yeah,
what are the block rewards actually supposed to be at any given point? And like questions like that.
yeah, totally.
But
Yes. I think this is exactly why I called this meeting a little bit, because when we started on Aster, frankly, we wanted to even make it possible to mine with Ketchup, and I was just solely focused on making sure this particular hashing algorithm would work and would be compatible with the existing Stratum and would work with all the clients. And to me, that was, I think, it might be that Aster at this point needs to stop living, right? And we should move on to bigger and better things, because I think it proved it's working, right? This particular algorithm has proven it can work. I believe we're still, we need Mantis support for Ketchup mining. There might be a discussion for the Mantis team. I know they're on the call, so they get a chance to tell us. But thanks, Isaac. Is that a good recap of what you guys are doing right now for CoreGeth? Is there anything else that you'd like to go over?
No, I think that about covers it. Chris, I think if you're here and if you're listening, is there anything else that you would like to add?
No. What you covered everything great as always. Thanks for that, Isaac. I don't have something more to add.
Right on. Well, that's it for us then.
Okay. Anyone from Mantis got an update on clients?
Sure, I can go ahead. Hi, Dom here. Thanks, Chris, thanks, Isaac, and thanks, Antoine, for the extensive introductions. And Chris, no, I don't thank Chris. Yeah, thank you, Chris, also. Basically, thank you all for coming and having this meeting. Regarding Mantis, we are kind of in this mode of discovering dragons in the code base. So we had a few setbacks regarding getting Ketchup running. The last setback was so major that we had to postpone getting it online. Just essentially, we were unable to connect to Astor, and the underlying problems were so fundamental that we had to just regroup. This should be out of the way, hopefully next month. Besides that, we're spending a lot of time dealing with the internals of Mantis itself. This is our main focus. So yes, we are catching up to Magneto, and hopefully we will be able to pick up the Mystic work fairly quickly. But our main focus is essentially internals. There are reasons for that, and there are, well, problems we have to get out of the way before we can move forward in a reasonable fashion. But the bottom line is that we are aware that the ETC network is moving forward. Magneto should be ready first half of next month. That's our current best estimate. Same as the other problems we had with Aster. So hopefully we'll have those 2 wins under our belt soon, TM. But yeah, that's the current status. Most of the team is basically busy with internals, with the code organization, and taking ownership of pieces of code that were essentially dead for 3 years. So there you go. That's, I guess, the short of it.
Thanks, Dom. Yeah, good luck. I know it's extremely hard to wrangle all the pieces of code to make a client work. So you have my sympathy. It's well understood. Thanks for the update. So the next item, maybe that I think is going to be just maybe a draft discussion. I don't want to discuss blocks or anything, but just maybe have a discussion about what Cody proposed and see if there's a rough consensus around this idea. So what is there a take from any teams here about this next possible upgrade hard fork for ETC? You can scroll down to comments. So there was a technical discussion about the base fee. Since we're not doing 1559, why do we bother with base fee? That's okay, we just return 0 all the time. So that makes the implementation of that opcode pretty simple.
I can comment on that. Apparently Solidity is not able, or they don't really want to bother for different EVM versions, and Solidity, which is the main smart contract language, is basically natively supporting this base fee opcode. This means that all EVM chains that does not do plan this 1559 upgrade, they will basically end up with a slightly broken functionality. So with this in mind, it might be worth considering to have some kind of stub for base fee. Basically just, I don't know what makes sense, but it makes sense to have something in place, even if it returns 0 or something, just to make sure to have maximum compatibility with all the tooling.
Yeah, that makes total sense. Thanks for bringing up this perspective. So
I wonder, on just to add on that point, and maybe this is because I'm not yet very familiar with this spec or with the implementations, but I wonder if it might be worth considering. 0 seems like the first and most obvious value for an inoperative code. But I wonder if it might be also worth just exploring relative to that a value like 1 that would be nominal and that would avoid problems like if people are doing divide by 0, or I don't know, if you have a contract on Ethereum that you expect base fee to never be 0, and you make that assumption in the code, then if the point is that doing math with 0 can sometimes be a little sketchy, and for contracts that care about overflows and stuff like that, using a value like 1 that's negligible would, I don't know, avoid problems like that. I'm not necessarily advocating that. I just want to put it out there on the table as just another option to 0, which is almost equivalent.
I think that's
basically would probably be the good place to look, because they'll have to worry about enterprise chains and things like that. So they'll have to work with this either way in their code base.
I could see also some knucklehead go with testing if base fee is 0, and based off that, find out whether we're in a whether EIP 1559 is applied or not. So just trying to see, if they're in a private network and base fee 0, do something, or do something else if you're on public. But I think it's all very conjectures. For me, I agree that it might be good to have at least a configuration setting that will allow people to set a fixed base fee, because it's useful for a bunch of different reasons. Okay, that's a good point. Maybe is there anything else that might be a way to also do that for the next hard fork? Is this a good scope, or is there more that we should add to this?
The alternative refund reduction might be, I guess, a little controversial. This is to stop the gas token. It takes the economics away from making anything off gas token, so it's effectively kills that whole community off and saves our chain and everything. But it does change some of the dynamics within the chain itself in the EVM.
Cody, are you familiar enough with that to give another 3 sentences about how it actually does that?
Yeah, it removes the refunds for self-destruct, and it reduces the gas refunds for S-Store to a lower level where the refunds are still sustainable, but it's no longer enough for the current exploits to be a refund mechanism to make money. So not deeply, I haven't deeply looked into it, but it basically just, you don't get anything back on self-destructs anymore. So
Yeah.
that's, I guess, one of the downsides of it is there's no encouragement for self-destructing and cleaning up after your contracts.
Mhm.
But it also keeps us from having a gas token.
I mean, my perspective on this one is we should align ourselves with Eve because they went that way. They made this experiment. They found out it was a bad idea. Let's go back, right? So I'm okay with this. I believe it's a fine idea to consider. The next one, 3541. I think this is actually just to have a register of contracts that we can reserve for official purposes. So in the case of the EF wants to be able to then later have contracts that would not be pre-compiles or would be special, so they can deploy that in that range, if I remember correctly. We can take a look. And
one thing we probably want to check with that one is just to make sure there's no contracts deployed on ETC mainly.
yes,
I know the check is done for Ethereum, but yeah, we need to do it for ETC as well.
yeah, that's a valid point. Definitely can go check for that. I think that was a discussion about that too. Yeah.
Yeah, and the further two that I have marked as admitted here, it's the 1559, which is the new economic model for ETH where it burns the fees, and the bomb delay, which we don't need because the bomb's already disabled.
Right, and thank you, Cody, for putting this together. It's really helpful.
I second that. Hats off to Cody.
Yeah, I mean, and I guess the important thing to take away here is none of these are like critical to the ecosystem itself. We have time to plan this out and get all the teams working together and get all the test nets activated on it. I mean, there's nothing here that's really going to shut anything down if it's not done before everyone's ready.
Right, it feels like we could wait for a month to just even do a little bit of research around some of those, and let Mantis catch up to us, give ourselves some time, and maybe have a discussion in a month time frame and see where we are and see what we want to do. Does that make sense?
Yeah, that sounds good to me. There's no security issues. I don't know of.
Right. Cool. Okay.
Do we know what'll happen now if Solidity calls for base fee, since it's not really an opcode? Will it just return an error if we don't have anything for whatever it is, like 48 or something like that?
Free, maybe, I can venture a guess.
Depending on the token, they should just better set the EVM version to Berlin.
Yeah, I would imagine it's a major upgrade of the Solidity language. So as long as you're under a certain version, you're fine. Just
That's true. That's what we did for a long time with the older Pragma. Like we were on 4.2 forever.
Yeah. Cool. So I believe that this one is a whole lot of work, and we need to talk a little bit about all of this. So, we've proven the point that Ketchup mining is possible. that we can have multiple clients come to consensus over Ketchup mining. We used a very simplistic network for that, where the first block is mined with Ketchup. There's no difficulty bomb. Everything is super simple. Everything just makes sense. Now, Isaac is like looking into this from a very holistic point of view of everything that needs to come into managing the difficulty and the consensus checks and et cetera, et cetera. And we did not even go into what it would take to do a transition between eFash and Ketchup, right? So there are a couple of things that I think we could do, and I would even make them, I don't know if it should be under the same ECIP, in my opinion, right? So I think there might be this ECIP, as far as I can tell, is done. We have Ketchup mining. It just doesn't apply cleanly to ETC. So the way now to engage and to make it possible to have a transition between the two is to think about all the flags and configuration that we would want to have for Ketchup mining. And I'm coming to that realization late because I was so focused on just even getting this stuff to work, did not even think about what it would take to bridge the two consensus layers. So one thing I would want to maybe offer with you folks is to have a way on the block transition to set a fixed difficulty for that block on that transition, because I believe this would be required at this time to be able to transition from maybe a very high difficulty block to a block of lower difficulty, because you expect that the Ketchup mining difficulty will be much lower, at least on that transition. Does that make sense?
Yeah, that concern definitely makes sense, and I think hard coding a difficulty value is definitely one way to do it. Another way to do it, and just to put out on the table, would be to consider the difficulty algorithm itself, because that's a fairly succinct function that could be modified to behave differently during a transition. Would be another way to go about it.
So, yeah, I mean, it feels like it wouldn't, to be clear, right? We're not setting a fixed difficulty. It would just be with resetting the difficulty at that block. And that is actually a pretty significant change to impact into this. I see it as a very interesting change to clients anyway, because so give you an idea, I had a discussion with some friends about what it would take to create a network that is branching off mainnet, any mainnet, right? Could be ETH mainnet. So if you wanted to do that, you would want to pretty much like take all the balances and all the states. You would want to be able to change the chain ID, and then you would be in a kind of a pickle because the difficulty of mainnet, for example, is so high. You would have a hard time being able to make it happen, to mine your first block into that new network. So instead of having a way to reset the difficulty on the transition block, helps everyone get a fresh start, and from there on, right, you're not setting the difficulty, meaning that maybe you have a lot more mining power, and so the first few blocks are very easy for people to mine, but then very quickly the difficulty algorithm kicks in and gets you back to safety into normal. So the first 10 blocks are going to be messy, but then it goes up.
Antoine, what's the adjustment delay for the difficulty?
I never know this. I think it's a % per block or so. So someone tells me I'm on plus or minus.
It's let's see, I have it right here actually. Maybe it's a small number. It's less than 1%. I think it might be 0.5%, or even it might even be, yeah, it might be 0.5%.
Okay, we'll go and model it and see what that means. I think the numbers are good. You don't want to be like Grin, where the difficulty took weeks to adjust.
Mhm.
When they did their transition, it was horrible.
Yeah,
Afri can probably speak to that as well.
I hear you. I mean, that's it. So pretty much the difficulties between Ketchup and Ifash have very little to do to each other. Like you wouldn't be able to, I mean, just to be clear, right? It's not because let's say Ketchup difficulty is 10x less than Ifash that the network is less secure, right? It's just about the difficulty in general of those two algorithms could not be really compared. You know, different things. So you should not read too much into that. The thing that you want to go for is to reach at equilibrium when you get a block every certain seconds on average, right?
Can you say what, if you have a sense of, so you said that they can't be compared. So by that, I understand that to mean that, that like, it's not necessarily the case that the rate of one hash is going to be equivalent to the rate of one hash across those engines.
Oh yeah.
Is that what you mean?
Yeah, that's what I mean, exactly. So having Ketchup deliver hashes, it's fairly easy, right? Because you're doing a different type of computation. We're just hashing once with SHA-3. So you could definitely see, even on CPU mining, I can do a fair number of hashes, right? So maybe if you really wanted to go and do a little bit of math, you take a single CPU core, right? You max it out and you see how many hashes a second you can contribute in terms of Ifash, and then you max it out and you see how many hashes a second you can contribute in terms of Ketchup. But even that comparison is going to be flawed because Ifash is super memory dependent. So you would have I mean, it's not really apple to apple comparison in my opinion, right? So I would just, I'm stating this not for you, Isaac, it's more for people on the call who might be thinking, oh, this network is less secure because difficulty went down. Well, that's not exactly how it works, right? On this one, because it's a different algorithm, so the whole thinking is different. We can go to a very high difficulty to really make it like, you know, there's a great video about that from Antonopoulos, who talks about mining, and you know, if you go to a target of 1, how impossible it would be for anyone to come up with a block that would satisfy. So we really have a very large band to find ourselves in a good position to mine. Again, to me, what's the problem would be that on transition, let's say you have a cliff where the transition, the difficulty algorithm is the difficulty level of Ifash is so high compared to how many miners are ready to mine on Ketchup, that you get a little bit of a delay before there's even enough hash power on chain to be ready to take this on.
And so because our intuition is that just the numbers, like the difficulty value, that scalar value will be overall, again, it's our intuition that will be a greater value for Ketchup than it would be for Ethash.
Yeah, I would venture to say that because I believe that Ketchup is going to be spinning more hashes, just it's easier to produce them, and you know.
And so,
go ahead.
And so having a transition block with a hard-coded low difficulty value is a very conservative approach, and it's an approach that favors frequency of block production, right? And so one thing just to keep in mind, I think that's fair. I'm very usually an advocate for conservative approaches. One thing that's just worth keeping in mind, and you may be already familiar with this, Antoine, but for anybody who isn't, the current difficulty algorithm will grow as we sort of speculatively said, like let's say 0.5% per block for blocks that occur within the faster than average band, which is like 1 to 8 seconds. And so that 0.5% difficulty adjustment is the maximum. For blocks that occur in the average band, which is 9 seconds to 17 seconds, then the difficulty is unchanged in the child block. But then those bands continue all the way from 18 seconds all the way to 60 seconds. Again, still in 8-second bands. And for all of those subsequent block times, the difficulty algorithm is designed to fall at, again, speculatively, 0.5% for each of those bands. So that's to say that like it can only ever, the difficulty can only ever increase by 0.5%, but it can actually fall by, I don't know, let's say 1% or 2%. I think it's less. I think when I'm saying 0.5%, it's actually probably 0.5%. But the point is that the difficulty is designed to fall much faster than it is to rise.
Oh, I see. Yeah, so maybe it's okay to be maybe over the top and then have a hard time, but for less time.
Yeah, well, and the problem with that approach, though, is that although the difficulty will fall faster than it will rise, in the case that the blocks are being produced slow, that it still relies on the occurrence of blocks to have that calculation happen. So, if it's the case that it's going to take 8 hours to produce the first block, then it's still going to take 7 hours and 50 minutes to produce the block after that. And that's a really long, even though it's falling as fast as it can, if you estimate too high, if you overestimate that difficulty, then yeah, it still might not fall fast enough.
Yeah. So maybe there must be a way where we can, if we were to make that transition, we would need to prepare some hash power in terms of Ketchup mining that could be ready on the testnet. And then we would be able to showcase that we have this much difficulty. And then when we set our sites on the transition block, then we would have a configuration parameter that matches what we see in terms of hashing power from that testnet. So we would have an idea of what the capacity of it is. And then we'd go for that. And either we don't do, I think we should have the option of setting a difficulty for the transition block, because I find it useful regardless of this upgrade, right? But it would be good to have an idea when or if that happens, right? So we can optionally put that into the configuration for the fork, and this way we can have a smooth transition instead of having to play catch up to the different difficulty adjustments. Does that make sense?
Antoine, how much hash rate do you want to see on testnet?
It's a very good question. I don't know. So there is out there a computation of how much hash rate you can buy, right? That is being singled out for eFash. I know that some miners been using that to compare the cost of 51% attacks and to understand, what would it take for me to create my own block and to take over the chain, right? So what's the cost of the hardware or land for that? And I think this would be ideally kind of the same thing you would have to do here, where you'd be able to say this much hash rate is going to cover for enough in terms of adjustment that will be safe, that won't be 51% attacked. So unfortunately, it comes down to economic terms.
Yeah.
But we've seen, GPU miners are able to create some pretty good, the hash rate of a GPU miner is pretty big. We actually have had on the Aster website, there's a complete set of statistics about the hash rate you can expect from different devices out there.
Yeah.
And as long as you can do like a market analysis and you say, okay, those GPUs were doing, millions megahertz of this, and then you can find out, divide the current hash rate on the testnet by that GPU, take the average price of that GPU and see what money that represents or how much you would have to do to rent it on AWS. Then you can actually do an economical analysis, even if it's completely ballpark, to see if someone involved into this could just rent a bunch of GPUs and make your life miserable. And of course, I'm leaving ASICs off that discussion because that is a different closed economic system. And right now, I wouldn't even know how to price them. I'm not aware of a SHA-3 ASICs because I just didn't look. Actually, I'm wrong. I think on the Astor testnet website, we have some of that consideration already. So we'd be able to do that as well. And you would compare the price of those different devices. You would find which device is the cheapest for the hash rate it provides. And then you'd use that and you'd find out pretty much what the cost would be to overtake the hash rate offered by a testnet. And pretty much after that, it's a campaign, right? So you go to the community and you say, if everyone wants to move to Ketchup, there is a testnet right here, right? It's mirroring mainnet. It's probably close to what we have, right, in terms of functionality and all that. Cool. If you have this level of hash rate, which compares to this level of money involved, right, then is actually more secure. You can even play this game where you can say the HeFash security is involving this much money in terms of hardware, and the Ketchup security, we're seeing this much involvement. Which one is better? Which one offers more security? And at that point, you can decide when to, or if you want to transition. So we're not there yet because we would want to be able to get to that operational level, I guess. And that's actually what I want to talk about right today. So this is a discussion we're having. I'm not saying that there's a decision made one way or another. In the meantime, for love, this Ketchup mining algorithm has been really cool. I find it to be a very elegant, simple solution where eFash was more involved and more memory centric. So anyway,
okay. Well, I'm going to send a couple of emails out to some FPGA miners I know and some GPU miners I know and see if we can get an idea of how much hash rate we can get on, and then stress test it a little bit more, or help with the projections.
Understood. Right now, to be clear, the Astor testnet, we're just focusing on interrupt between different, making sure that Ketchup mining would work and would be compatible with GPUs. We even had like the first GPU implementation of that Ketchup hashing. So it was more like, let's prove the point it works, right? Now we're going beyond that. And I believe it would be worth it to even have a way to show some real transaction activity, have some real activity on it, not just have it be a science experiment, right? So I would be in favor, and there might be a discussion that we can have on Discord or elsewhere, to shut down Astor or restart a new Astor-like testnet where we have more state, and see where we go from there.
Okay, we can the miners probably only conducive to doing that for a short time, as there's an opportunity cost of mining. If they're mining ETH and making money, then anything they put on PT is opportunity cost.
In that case, we'll do a campaign where we say a little bit like what miners did earlier this year with Evermind, where they moved all their traffic away from it. I will ask miners to say, from that time to that time, during that that pocket of time, can you show your support, and we'll just monitor the hash rate for that duration. Okay. And that will give us an idea, but we don't have to do it right away. I think also my personal position on this is that Ketchup mining is a good deterrent. It's like having a tool on your tool belt. You want to have it ready, right? but we don't have to. I don't think there's an emergency to go to that yet, as far as I can tell. So I'm waiting and gauging community sentiment on that, and just listening to everyone. But in the meantime, just going to continue having fun with it.
Okay, well,
No,
okay, we'll discuss it more on Discord or on Telegram. Get it figured out.
Sure thing. And I believe that was it. So for the CoreGeth discussion, I think one thing you said that was interesting, Isaac, is sort of ugly since much of the specifications are explicitly for eFash. I agree with that. So there's a number of things around difficulty bombs or things like that that were like eFash specific. And then when I ported my Ketchup thing, I just copied over your code because that's how lazy I am. And all the flags came over, right? And then I started deleting those because they were getting in the way where I'd block 200,000, the difficulty bomb started keeping in. And I had not thought about that. So if we want to have equivalent flags for Ketchup, I agree that we should be having those and they should be separate from eFash. Does that make sense, Isaac?
Yeah, that makes great sense. And, I think it's sounding like we're sort of, beginning maybe a conversation about like a next test net.
Right.
Yeah, which I think is probably a strong idea and gives us an opportunity to design something that hopefully can be really useful and really educational for us. And the liberty that we'll have with the tabula rasa can be really good, I think.
Yeah, I mean, I would risk it to put you on the stand and say, hey, if you have a design for a difficulty bomb mechanism or something in mind, this is a good time to bring up ECAPs, because right now there is nothing. Like you've seen, right now we have pretty much no configuration whatsoever. So if Ketchup mining goes through the roof, we don't have a way to stop the chain. We don't have anything around difficulty bombs whatsoever on this thing, right? So if you want to have a way to harness this stuff in some way, it's a good time to bring it up. And beyond you, Isaac, everybody on this call, if you have an opinion on how this should be configured and wrangled, I'll do it now before this stuff goes ever close to life, right? It's a good time.
So a couple of things I'd like to see on some of these go for any test nets in this context, but for this case, I'd like to see all of the I'm not sure before I even say this. So because this is being done in the context relative to Ethereum Classic, or at least like that would be sort of the first step that I would want to make, just from a design statement standpoint, and say, like, we're designing a test net that's intended to be relevant for Ethereum Classic. And then as soon as you say that, then you can start adding designs like, okay, well, Ethereum Classic has had these forks historically, and so we'll want to have also these forks on this network. I mean, for me, I think that's an important thing to see, instead of squishing all of the forks and say, okay, well, we'll start from Magneto and go onwards. I think it's important to say, no, we need to actually like play through these forks in order, so that we can make sure, because that all of the configurations are right. In my experience, the majority of bugs with problems like this are going to be at least configuration related, because so much else can be unit tested. So being able to mimic the upgrade pattern and history as relevantly as possible is going to be important. One thing I also think is that in terms of thinking about if we want to do the transition from eFash to Ketchup, if that's something that we want to take on this testnet from the beginning, we don't have to, right? One of the things we can do is like go through the normal process, just like you would with any other chain. Is you define your initial configuration, and then 2 months in, you decide you're ready to make a transition, and so you just implement that and implement the configuration, decide a block number, and then have a fork.
Right.
And one thing, though, that at least just sort of from a very high level, I think might be interesting would be, and again, this is just brainstorming, but it would be, if we're thinking about doing that transition from Ethash to Ketchup, that I think it might be worth exploring having a series of transitions. So like to go from Ethash to Ketchup, back to Ethash, back to Ketchup, back to Ethash, back to Ketchup. Just so that you can have more than one shot at what that transition, most importantly from Ethash to Ketchup, is going to look like. And also so that you have sort of accidentally, you have this safety, I don't know if I want to call it a safety net, but you have the reverse already practiced and already figured out, so that, if it does ever want to approach and be implemented on a real network, then you have sort of accidentally already the code and the practice of undoing the upgrade, which
I like that. I like that.
might be interesting.
Yeah. Fair enough. That is great. Thanks for bringing that up. So by the way, I'm going to, after this call is done, I'll take the recording, I'll write some notes, and I'll share that on this issue. But yeah, this is a great idea. So I think that's a follow-up for us to look into the testnet makeup and how we go about it. Okay, cool. So I'm feeling pretty content. I think like this ECIP now is reaching its logical end. Like we proved the point. Now let's open more, right? And let's go. So hopefully we'll see how this PR goes. But I think it depends now on other things around the configuration flags on CoreGeth. So you folks have it. I'm not going to intervene or continue coding on that, Isaac, unless you tell me, hey, I need your help on this particular thing.
Yeah, no, the only thing while I have you here is just to ask you in person if it's all right. I think we'll push up another pull request in lieu of replacing yours, just only because we rebased it on master. So there's going to be incompatibilities in Git. But if you're okay with either just moving to the next PR or having us force on your PR.
No, that's fine.
Okay.
You do whatever you want.
Okay.
Matter to me. So at the end of the day, the goal is to get that support inside CoreGeth, not how we go about it. So yeah, no, thanks for asking. Don't feel bad about it. It's your project, you own it, right? So
yeah, well, there is your work, it's your commits. So. Yeah.
I understand.
Yeah.
Okay. Well, yeah, no worries. I understand where you're coming from. So yeah, by all means. Okay, one last item on the agenda that I think is relevant here. EF66 support that is coming up to Geth, and I think it would be good to agitate that to our friends at Mantis. Folks, EF66 support changes the way you would think about message exchanges inside the client. So if you're already catching up and having issues with the way the client communicates, EF66 actually makes your life much easier, because it adds an identifier to each request and response. So before, we had to make some guess about, I sent a request and I would like to see a response, but I can't remember what exactly I asked for, and I get something it doesn't really match, but okay, fine. So you have to do keep a lot of states around to make sure that you're getting what you thought you were getting, right? So some languages like Go, you can actually get away with it because you can do all sorts of things around coroutines to kind of keep the state in there that doesn't feel too ugly. But for example, in Java, and I'm guessing in Scala too, because it's pretty close, you would have to now have a mental model about how you communicate that, right? So with E56, they changed everything. They added a wrapper that actually identifies every request and response. If you get a response, don't have a request for it, that's a disconnect right away. Everything else just works. You can have timeouts for any request not coming back to you with a response in some allotted time. And so your whole logic for your communication layer goes from huge to 5 lines. So if you want to save yourself some trouble, my opinion is go for if66. Don't even try to support anything else in between, because you're gonna get yourself into a lot of trouble. If no, in saying this, Besu doesn't have if66 support yet, but it's in progress and it's been fast tracked because we just had a call this morning where the Geth team again said we're going to remove all other if subprotocol versions, but the if66 support in our next release that's coming up in the next 2 weeks.
Yeah, well, we're aware, but thank you for making it plain and obvious that we need to move to it.
Yeah, I mean, hopefully it's helpful. If it's not, it's okay. You can disregard.
No, that's very helpful. It gives me more urgency around this topic.
Okay. I know Besu will keep compatibility back to FT65 and lower, just because there are so many Besu private networks that have versions of things. They support quorum as well, so they need to have some level of backward compatibility. So it's not going to be disregarded or removed from Besu anytime soon. But FYI, I mean, I would say 6 months to a year from now, we would gladly get rid of that additional code if we can. Hopefully. And for the CoreGeth team, do you have if66 support this time? It's really hard to say. If66.
Yep. Yeah, we have 65 and 66 support.
Oh, okay, cool. All right. Then.
Yep, and Snap One.
Awesome. Okay, then in that case, pretty much Besu needs to catch up to that, and we will be in a good shape going forward on that. Awesome. Okay, got 3 minutes left. Anybody got anything that they want to bring up? It's a good time.
Yeah, this is Cody. I'd posted something in the chat. Isaac, you'd mentioned creating a test net that was more similar to what the main net is.
Yes.
And the easiest way to do that would probably be just to fork the main net for a test net once all the clients are online. Just set a block number, and then the clients that fork off will be on that test net.
Yeah. I agree. I want to fork mainnet. That's a lot more fun, because then everybody's got already accounts and balances, and then we can go play a lot harder than if we have an empty testnet with just a faucet.
Yeah, and if you need to, then you can. If you're creating a fork and it's a testnet, no one would probably have a problem with creating tokens just for the testnet, putting it in dev accounts or something like that.
Right. Yeah.
Yeah.
Right.
Great idea.
Yeah. For what it's worth, a friend of mine came up with that idea for the Eve mainnet. They wanted to create a testnet that is forked off mainnet, and then is kind of running ahead of mainnet, makes all sorts of weird promises, breaks, plays with. But the interesting part was that if everybody gets the balances in that new mainnet, it's like an airdrop, and then all of a sudden you have the ability for everyone to continue playing. So it gives it's much more real in a way. So. All right, folks. Thanks for attending. Feedback is important to me. Anything you want to, you saw that could have gone better. Any questions you may have, you can reach out to me on Discord. You can ask me questions. I try to make myself available for anything. I think what we're going to do is we're going to have another meeting in a month. We'll then catch up, and it will be kind of a similar agenda where we have a check-in from the teams. We'll do another check-in on a hard fork for Mystique, and we'll see if there's any other topics of interest for the team. Does that make sense?
Yeah. Thank you very much, Anton, and bravo. Well led.
You're welcome. All right, cheers. Bye.
Thanks, Antoine. Bye.
Thank you. Bye-bye.